Enthalpy change of atomization. What is the concept of atomization? First of all, we have a symbol delta H ATM with a special symbol above it, which is showing the standardization. Chemistry has always a concern that if you conduct an experiment at a very low temperature, or if you conduct an experiment at a very high temperature, the results always differ. It's just like very simple. If you see in winter, we feel cold, and in our summer we feel hot. Why? Because in winter surrounding temperature goes down than our body temperature, so we lose heat. So when we lose heat, we feel cold. And in summer, the surrounding temperature goes higher than our body temperature, and as a result we start absorbing heat and our body temperature rises. So it's very interesting physics example in chemistry that actually we ourselves throughout the year undergo exo and endo behavior. Our body sometimes is in an exo thing, sometimes in an endo thing, and we also reach an equilibrium. It's a very hot day, you're coming outside and you enter a room where air conditioner is working, you have a very pleasant feeling, but after few minutes, even just like 15-20 minutes, you feel that now the stable temperature is there. So this is the issue of temperature, pressure, and concentration. Under different conditions, the results will vary. So they decided to set some permanent conditions of temperature, pressure, and concentration. This is called standardization. Now, our next concept, this is a revision concept, that standardization. Now, our second concept for today, what is atomization? Substances, substances occur in a molecular colony style that the atoms, molecules, they have a bonding with each other, maybe solid, maybe liquid, like this. So molecules attach with each other and they are bonded together, maybe in solid, even in gas. Some weaker attraction forces like van der Waals forces, like dipole forces are there. Atomization means split the atoms, separate them completely. So split the atoms like this and take them apart, totally apart. If you have a taste of eating grapes, it's a very good example. Grapes, they are small, juicy balls joined together, and you detach every one of them, and then you spread them on a table. This is called atomization. Atomization means separate the atoms, and move them apart. So if it is Cl2, Cl2 means two chlorine atoms are bonded, break the bond, separate them well away from each other. If it is sodium, sodium solid, so these are sodium solid atoms joined together, torn them apart away from each other. And if you separate them fully, this is atomization. So my first concept, sorry, second concept, what is atomization? It is basically a concept of separating the individual atoms in the original given state. For example, ClCl, you break the covalent bond, the bond breaking, the reaction is endo, and this is called atomization. It's a solid sodium. You convert it into gas. Why gas? Because in gas, atoms are far, far away. This is atomization. Now look at this concept. Half H2 gives you H. This is atomization. Half Cl2 gives you Cl. Sodium solid to gas. This is atomization. Now, uh, have you given the heading atomization?
Yes, sir, I have.
Okay. After giving the heading, after giving the heading, uh, right under it, can you repeat the concept? What is, acha, first I repeat, then you repeat. Huh? Enthalpy change of atomization as a concept. Definitions are memorized by word to word. This we discussed in our last chemistry class. This is where chemistry for some people is very scoring, and for some people who are good in physics, chemistry is a bit troubling because chemistry want these definitions, the descriptions, the discussions in a good, proper wording. Unlike physics, where you can write down your concept, that's fine. Here, not the concept only. You have to be very formal with the words. After bio, chemistry is the most formal science. Acha, what's the concept of enthalpy change of atomization? It is the energy required to break the bonds between the atoms and obtain a gaseous state where all atoms are well away from each other. This is the concept. Okay. Obviously, first the concept matter definitions are part of memory. So can you repeat the concept? What is enthalpy change of atomization?
Sir, it is basically it is the energy which is required to break the bonds between the atoms and obtain a gaseous state.
Hmm, right. Good. And the concept you got that it is basically atomization is basically the concept where you separate everything. So let us write down the definition together. So let's write down the definition together. Energy, the energy required or absorbed, the energy, the word can be written here, absorbed, or the option is to, you can also write the word required. In the paper, you have to write only one word. You can't write you can't write definition in brackets or in option. When 1 mole of 1 mole of an element 1 mole of an element is converted into gaseous atoms under standard conditions. So please copy this.
Done, sir. I copied it.
Good. Now we move to the equations. Equations are necessary to follow. Equations are necessarily to follow the definitions. They always want people to memorize the definitions, and the equations should be in accordance with the the equations should be in accordance with the definition. So here you can see the example. You should notice that balancing is deliberately in fraction so that the right hand side does not get any other number other than 1. So you have to now copy this.
Done, sir.
Now we had a data booklet. Now it is getting obsolete, but there used to be a data booklet, and in data booklet, bond energies were given. Now we have a concept. This will be our next concept for today. That enthalpy change of atomization, enthalpy change of atomization is half of the bond energy. Enthalpy change of atomization is half of bond energy. So if you have the bond energy and you halve it, you will get the enthalpy change of atomization. So now you have to copy this knowledge also.
Done.
Atomization. This is the process. Atomization is a process in which you are going to provide energy. Why you are going to provide energy? Because definitely you have to separate the atoms. So atomization enthalpy is always, endo. And the logic is there, that you need to provide energy to separate the bonds. Enthalpy change of atomization is endo. So you have to copy this.
Done, sir. Also, sir, like the bond enthalpy or energy is we need it because it basically tells us how much energy we need to provide, right?
Hmm. It's a reverse of it also.
Yeah.
Now give the heading bond enthalpy. Now, as chemistry is formal, as I always say, these terms are not uses, these terms cannot be used in general sense, like bond is a word which is used for all types of bond, but chemistry is a specific. The word bond is used for covalent structures. Like sodium chloride is an ionic compound. So you cannot say bond enthalpy of sodium chloride. Why chemistry results are even in more problem in compared to physics? Chemistry is not able to be more precise. So sodium chloride does not have a bond enthalpy. Yes, hydrogen chloride has a bond enthalpy because it's a covalent structure. So the first concept to be made that bond enthalpy is a specific for covalent structures. Energy required to break 1 mole of gaseous bonds to form gaseous atoms. Under standard condition is always there, not writing it here. So this is the energy required to split the bond, break the bond, and the better idea, the better word is bond cleavage. So you basically separate the molecules, and the word delta H bond is specific for covalent bond. There are two types of covalent bonding in our course. One is called pure covalent. Second is called dative covalent. What is the sense of using the word pure? Because in bonding, you must have read that in A-level chemistry, we make a new concept that bonds are not precise. Some people think that sodium chloride is perfectly ionic, but chemistry says no. Nothing is perfectly ionic. Nothing is perfectly covalent. It's always like a dual character. Just like in every person, there are some good things, there are some bad things. So it is always like a structure and ionic structure. They are always coexist. In some molecules, in some substances, covalent behavior is more prominent, like HCl and other one, but they have some ionic character also. So in A-level chemistry, we have a very interesting rule. Every covalent bond has some ionic character, and every ionic bond has some covalent character. That is right. One character is dominant. So we say NaCl is an ionic compound. That's right. But it has a little ionic covalent character also. See, similarly, HCl is a covalent structure, but it has a definite ionic character also. So this is our next concept. We have to copy this.
Sir, I copied it already.
Very good. These are the bond energies. You can notice
So
that
yeah,
like
we need more bond energies for like double and triple bonds.
definitely good. And you can notice that the highest bond energy available here is N2. N2 is 944.
Yes. Why is that, sir?
For
Hello.
nitrogen to nitrogen, triple bond.
Yes, sir, but like even the carbon to carbon triple bond, it's not as high as the nitrogen one.
That is obviously carbon. Na?
Oh, okay.
Very simple, like in our understanding, carbon overlapping and nitrogen overlapping won't be equal, but in sense of nitrogen, it's overlapping. This is a chapter, this is a topic coming from bonding, and you might remember the theory of orbital overlap, s orbital, p orbital. So this determines the extent of bonding. So look at nitrogen to nitrogen, nitrogen to nitrogen. It is a triple bond.
Yeah.
Our next concept. Bond energy values are average. They can fluctuate. They're not absolute because of the environment in which the atoms are, because of the intermolecular forces. For example, in methane, the bond energy of carbon to hydrogen is different from the carbon hydrogen bond energy in benzene because of the environment. So, what is our next concept? Bond energy values are average. Bond energy is a measure of the strength of a bond. So, if bond energy is high, it is difficult to break a bond. For example, a famous trend in our chemistry is the hydrogen halide, HF, HCl, HR. You can notice that down the valley, the bond energy is decreasing. When the bond energy is decreasing, reactivity is increasing. Why?
Because they are easily able to get into chemical reactions.
Good. Bond energy is a measure of the strength of a bond. So we have strength of a bond always depends upon environment. We use average values. Now, a very important concept comes in. Bond forming is exo. Bond breaking is endo. For diatomic gases, we always double the atomization, and smaller bond energy means weaker structures. Now, for example, when you see this terminology, when you see this terminology that some molecules are diatomic, some are triatomic, some are monoatomic, it's coming from our IPS chemistry, that this depends upon the this depends upon the octet rule. Some atoms like helium do not make any bond at all. It means they are stable. They have no issue to make any type of bond. So now make our next important concept. The next important concept is there that bond breaking is bond breaking is endo and bond forming is exo. Bond breaking is endo and bond forming is exo. Bond breaking and bond forming are the bond breaking is endo. That's logical because when you want to break something, you have to provide energy. Chemistry says that actually bond is not like a glass which you break. Bond is not like a rod which you break. Bond is basically an orbital overlap. I hope you have the famous theories like hybridization, molecular orbital treatment, valence shell theory, in which we say s orbital, p orbital. So, chemistry always says that bond breaking is not like breaking of something which is solid. Bond is actually an overlap of the atomic orbitals. That is why in all the good books, you will find the word bond cleavage. It's like a reversal of the overlap. Acha, if you make this concept, then you understand that bond forming is not like joining something like we used to join the blocks in our childhood to make something. It is not like that. It is basically orbital overlap. When two orbitals overlap in order to attain octet rule stability, noble gases, so in that case, the orbital overlap increases the stability, due to which the reaction is exothermic. AS chemistry has a simple rule, no details needed. AS physics like that details are not needed. In A2, you will be required to understand more details. So every topic is like a flip, like a flashcard. You see a concept, you just make a good point about it. That's all, no details. So that's why we always tell our students that AS physics, AS chemistry are like flashcards. You memorize few concepts. You are not supposed to go in detail. So book reading is never helpful, not required in AS. A2 is required. Here you have a simple rule which I repeat in every class. Actually, I repeat in my every class and every day. So when I go to a college and I'm teaching, so all my students are waiting. Now he will say that do past paper questions, do whatever you do, whatever time you get, do past paper questions, one question, two questions, three questions. So I tell them, look, the reason is not that the reason they are not going to give ask you any people. Cannot ask you what is the theory of morbid molecular orbital treatment. Ask nothing like that. Now we put our next concept, the enthalpy change of reaction. We put our next concept, enthalpy change of reaction. Sorry. So now you have to give a heading, enthalpy change Now copy this. Give this edit.
Sure, already did it.
Good. Now make a concept. I am going to discuss this concept with my writing that this is again a concept coming from our previous discussion. The concept says that in every chemical reaction, this is a definition which I'm taking from IG. Older bonds are broken and consequently new bonds are formed, and consequently new bonds are formed. This is this means what? It means when you say older bonds are broken and you say new bonds are formed, what it means? It means every reaction has a endo part and an exo part. That is to say, every reaction is partly endo and partly exo. Now look at this concept. So can you understand this concept? Why every reaction is partly exo and partly endo? Because in every reaction, both the features are there. They have an exo feature and they have an endo feature. So every reaction is partly exo and partly endo. Then how we decide what is
Sir,
the
can you sir, can you give me an example?
no, it's every reaction. You can talk about any reaction. In every reaction, older bonds are broken. Now, when older bonds are broken, it will be what? It will be endo. And
Oh,
when you make any reaction, C plus O2, CH4 plus O2, you think about any reaction. In any reaction, you break the older bonds, so you have to give energy. And you basically form new bonds, that is exo. Now, what is the next concept attached with it? Now, what happens to now how we decide the how we decide the overall enthalpy change then? Every reaction is endo and exo. So you will tell now that overall the enthalpy change of a reaction is the outcome difference of the endo and exo parts. So it means in every reaction, you break the older bonds and you form the new bonds. So in every reaction, there are two phases, exo phase, endo phase. Then how we decide overall it is endo or overall it is an exo? It depends upon the energy amount. So for example, bond breaking took 100 joule and bond forming involved 80 joule. So reaction would be overall endo. For example, bond breaking took bond breaking took 100 joule and bond forming involved 120 joule. Exo has a bigger share, so the reaction will be overall exo. So this is a concept of mathematics. This is a simple concept of mathematics, that how a reaction becomes exo or endo overall. This word overall actually means that what is the numerical result, what is the numerical result, and if the numerical result is more exo, the reaction will be exo. So, so for example, bond breaking is 100 joule, which is endo, and bond forming, which comes after that, is 80 joule, which is minus. So overall, what do you predict overall about the reaction? Overall, the delta H of the reaction is what? Positive. It means the overall reaction will be endo. So can you understand this concept?
Could you repeat, sir?
In every reaction, it in every reaction, the first stage is bond breaking and the second stage is bond forming. They
Okay,
both,
yeah, got it. Got it.
it is just like a business. Across the month, you have some profits, you have some losses. By the
Yeah.
end of the month, how you decide overall it's a profit or loss?
Yeah. Okay, thank you.
How we decide it? A profit of a month, you will see all the plus and you will see all the minus. If the total profits are greater than the total losses, it will be considered as what? It will be considered as the overall profit. So when you say, so it means what? It means, so when a reaction, when a reaction is exo, like for example, when a reaction is exo, like CH4 plus O2 gives you CO2 plus water. Now, this is an exo reaction. So when you say a reaction is exo, what it means? When a reaction is exo, like this one, what it means? It means that when a reaction is exo, so when a reaction is exo like this, it means that bond forming, bond forming is more, bond forming is more energetic than bond, bond forming is more energetic than bond breaking. So can you understand this concept now? When you say the reaction is overall exo, it means internally, like a business, in every reaction, there is some plus and there is some minus. And how we decide overall it is exo or endo? It is overall exo or endo depending upon the number. If bond forming is a bigger number than bond breaking, the reaction will be overall exo. This is the theme. Now, some reactions, as we discussed in our previous class, some equations represent dual nature. Like this is a reaction, H2 plus half O2 gives you H2O. This is formation of water, but simultaneously it is combustion of hydrogen also. These equations have a dual meaning. Now give the heading measurement of enthalpy change. Give the heading measurement.
Answer.
Now, enthalpy change is a very important title, discussing with the fuels, discussing with the energetics. discussing with the use of chemicals for any proper purpose of propelling something. So when you are using petrol in your car, it is a study of energetics. When you are using a rocket fuel to launch the rocket, it is the study of energetics. There are two ways we can measure the energetics. One is called direct method using a calorimeter, and second is indirect method using Hess's law. This is our next title. You have to copy this.
Done, sir.
There are two methods. One involves calorimeter. Working of calorimeter is not required. It's only a concept that calorimeter. What is a calorimeter? The word calorie means actually energy. Calorimeter Calorimeter is an apparatus which can hold the energy, no losses, like a ice box, like a refrigerator. It's a closed container. Calculation based upon calorimeter. Q is equal to mc theta. The letter theta can also be delta T depending upon the physics background. So this formula is coming from physics. Q is equal to mc theta. So you have to now copy this.
Done, sir.
Right. The value for C for water is a constant, and it is 4.18 joule per kg Kelvin. This is a constant given in the paper. This is called the value of C for water. Calorimeter is basically calorimeter is an apparatus which can record the temperature rise, and it doesn't allow heat losses to surrounding. So normally when you are using calorimeter, water is a common solvent. As water is one of the most common solvent, we refer to the specific heat capacity of water. But as a physics student, you should remember that or other solvents can also be involved. Calculation Q is equal to mc delta T. This is the formula. This formula is used to calculate enthalpy change in a letter formula. Now, for water, 1 liter is equal to 1 kg. This is a convention that for water, 1 kg is unit of mass and 1 liter is the unit of volume. They are equal. So when we say it is an exo reaction, it goes up the graph, and when it is endo, the reaction goes down. So this formula can be used to calculate enthalpy change. Now, once you calculate delta Q, then you need to calculate enthalpy change. Enthalpy change is delta Q upon N. So what you do? You first calculate delta Q, then you divide delta Q by N. N is the number of moles. So you have to just read the paragraph and just only the paragraph to be read, but copy the formula under it.
Done, sir.
Now, this is another important concept which should be in your memory always, that standard enthalpy change and the regular enthalpy change are never equal. They're always two different concepts to different values. This apparatus is called calorimeter apparatus. Calorimeter is basically used to determine the energy change or temperature change accurately. Now, this is a review sheet. You have to memorize this sheet. That first you determine Q is equal to mc theta. Then you determine delta H upon N. You have to memorize all of these things. You have to observe it. I will post it on the chat for reference also. But you have to memorize these all boxes.
Okay.
So this is the concept here. Now, one complete combustion of this hexane raised the temperature of 100 gram of water from 22 to 47. Calculate the enthalpy of combustion. You just need a periodic table with you. No need to copy the question. Just take up the calculator, look at the data and find this for me.
Okay. Um, 18.81. And
18 point.
then, yeah. And then I think we need to divide it by the number of moles.
Okay. So first you determine the heat capacity. First you determine the heat absorbed and then you divide it by. So answer after you divide the moles. So the final answer is 5,000 kilojoule per mole. Can you compare the working?
Yes, sir.
Is it matching?
No.
Okay, no problem. Just look the working again. I'm just coming in a minute. Look up the working and fix it. I'm just coming.
Okay, sir.
Uh, did you get the answer right now?
Yes, sir, I got it. I accidentally like multiplied 0.18 into 4.18 and then 25. Sir, why did we use 100 instead of 0.18?
We use 100 for
For
mass.
the heat absorbed. Yeah.
Mass, we always use the mass of water now.
So 0. Oh, okay, okay. Okay, sir, got it.
Are you clear why we are using the mass of water?
Yeah,
100,
because the heat absorbed by the water.
because water is absorbing the heat.
Yeah.
Okay. Now, 25 cm cube of 2 molar HCl was added to 25 cm cube of 2 molar NaOH in an insulated beaker. The initial temperature of both solution was 20. The highest temperature reached by the solution was 33. Calculate the molar enthalpy of neutralization. The specific heat capacity C for water is this. I have given you I have given you the reaction also. No need to copy the question. You have to read it and you have to try to understand that how this reaction will occur. We always, in A-level chemistry, we always take care of limiting reactant because sometimes one of the reactant is given in greater amount. If any of the reactant is given in greater amount, that will be the excess reactant. Ratio is always applied. Ratio is always applied according to the limiting reactant.
Here,
Yes. Have
can
you
you
read it?
send? Yes. Can you send me more questions for chemistry as well, like you did for physics?
Yes. I forgot today. I will inshallah try my best to send you some questions today for
Okay.
the past paper work. Acha, did you start this question?
Yeah, I'm going to start now.
Okay. Now, first thing you have to do is to find the number of moles. This is the situation. This is 25 cm cube, 2 molar acid, 25 cm cube, 2 molar alkali. So you combine them, you get a solution of 50 cm cube with 50 cm cube water means 50 gram mass. 50 cm cube water means 50 cm cube mass.
Okay.
So this is the first stage. Let me share the question on the chat. Is our reference. Now, I have shared
Sir?
it on the chat, so you can read the question from the chat and we can scroll forward and you can start the working with me and you can read the question from the chat. This will be like a gallery also. And now you can, now, first stage is to combine the two solutions. We have combined them. Look at the first step working. Copy the first step working. We have combined them in a single solution.
Hmm.
So you have the question now. If we do not complete it in time, still you can do it. Now I will now
Yeah.
see temperature change. Can you hear me?
Yes, sir.
I do the temperature change now. Look at the temperature change. Delta T is 33 minus 20. 33 is the mixture temperature. Now copy this also.
Done, sir.
Then use the formula Q is equal to MC delta T and find the value of Q. You can see the working.
Yes.
Once you find
Sir, do
the
we always have to turn it from joules to kilojoules?
this is a good question. This is required. Yes. Then
Okay.
compare the moles. Now this is the time for the moles entry. You determine the moles of HCl. You determine the moles of NaOH. The ratio is 1:1. So no one is limiting, no one is excess. So then you are good to go to use any of the moles. So you compare the moles.
Done, sir.
So then divide by the number of moles. The last step.
Sir, do we always need to check the limiting reagent?
Yes, when two reactants are involved, we always do that.
Okay. Even if like they didn't ask for it?
Even if they do not ask for it, you have to check in the. I will show you more questions that how you get the idea to check.
Okay, done, sir.
Good. So we are stopping here, and we will inshallah continue in our next class.
Okay, thank you.
Good